The question we are going to solve now belongs to test series 1. It is of network theory subject. In specific, it belongs to DC network solution methodology. As per the question, there is a DC network given which contains a 10 volts voltage source and a 20 volts voltage source which are connected by 1 ohm resistor, and this combination is in series with a parallel combination of R ohms and 4 ohms, and the whole combination is in parallel with 4 ohms. There is a resistance of 1 ohm connected in between the terminals A and B. This is the DC network given. It is given that the maximum power Pmax is transferred to the 1 ohm resistor for the configuration shown. Then we need to find the value of R. It means that we need to find the value of resistance R such that the maximum power is transferred to the 1 ohm resistor. So here if we consider the load resistance RL is equal to 1 ohms, we see that maximum power Pmax is transferred to the load resistance. It means that the load resistance RL should be equal to the Thevenin's resistance as seen from the terminals A and B. That is, the Thevenin's resistance as seen from the terminals A and B should be equal to 1 ohm for maximum power transfer to the load resistance. So we need to find the value of R such that RThAB is equal to 1 ohm. So as the circuit contains only independent sources, we can find the Thevenin's resistance RThAB by replacing the voltage sources by their internal resistances, that is by short, and by replacing the current sources by their corresponding resistances, that is by open. Upon doing that, we get the equivalent circuit as shown. So from this we see that the Thevenin's resistance RThAB is equal to 1 ohm is equal to R in parallel with 4 in parallel with 4. Please note that the resistance marked now is shorted. From this, upon simplification, we see that the resistor value R is equal to 2 ohms for maximum power transfer to the load resistance 1 ohm. So the required value of R can be written as 2 ohms. Hence, the correct option is B.